All right, let's get started. It's 5:30 here. My name's Alain Maillot. I'm a developer on the Smart Glass platform team in the Xbox One Smart Glass world. Today we're going to talk a little bit first about what Smart Glass is, what second screen experience is, what it means to extend an experience from a console to a device. We're going to look at some of the companions that have shipped, and we're going to talk about the scenarios that they fulfill. We'll talk a little bit about Smart Glass SDKs, what options are available to you as a developer. We'll do a demo, I hope. It's still deploying from my machine right now. That's why we're a little late getting started. And then I'll leave some time at the end for Q&A. So what does it mean to extend an experience to a device? Well, I'm sure all of you are familiar with the idea of watching a TV show and seeing a hashtag pop up in the corner. And that's an example of a really, really simple extended experience. It's taking content that's happening inside a title or inside a movie or a TV show, and it's extending it to you in a social way. And so you can go on Twitter, you can go on Facebook, and you can see a conversation that's happening. Well, this is an area where lots of companies are investing, and they see it as an exciting way to connect with their users, or the consumers of their content. So they're starting to build these companion experiences that go beyond just a hashtag or things like that. And we're starting to see this already. People are building mobile apps that go along with their TV series or their movies. They're building additional sort of augmented games and things like that that connect users with the worlds that they're interested in learning about. And they're doing this today without Smart Glass. So Smart Glass is not required for any of the things that we're going to talk about. But Smart Glass is Microsoft's way of sort of getting you as developers engaged with that type of audience. So what is Smart Glass? Just a quick show of hands. How many of you actually know what it is? That's the most number of hands I've ever seen gone up when I asked that question. For those that aren't familiar, Smart Glass is branding, really, that we use to describe several things. We think of Smart Glass as a platform. It's a bunch of technologies that we build together to enable scenarios. But Smart Glass is also an application, and it's an application that has shipped and is available to all of you today. You can go and download it on your Windows phone, on your Windows 8 device, but also on your Nexus or on your iPhone or whatever you're interested or whatever device you have in your pocket, Smart Glass is available for that today. And finally, Smart Glass is also an SDK or a set of SDKs that's available to developers, Xbox developers specifically. Now, Smart Glass as a technology enables several things. And I won't go into depth on these too much, but it's important to kind of understand what it gives you or what the technology enables. So the Smart Glass technology enables discovery and connection of Xbox One consoles on your local network. So if you're connected to the same Wi-Fi network, Smart Glass technology handles how you actually connect with it. It provides authentication to those connections. So every single connection in Smart Glass can have a user associated with it. So if you're a developer, you can take advantage of that and go, I want to build an experience that connects the user that's on the device with the user that's on the console. And it's a really powerful thing to have. Smart Glass technology also enables things like controller input and text input, which we'll talk a lot about in depth later, but it's just worth mentioning that there's a lot of platform work that happened there. Smart Glass also provides context and app management for what's going on. So Smart Glass is aware of what's running on the Xbox, what title is running on the Xbox, and it allows the users to take control of that, and it allows developers to facilitate that control. And finally, Smart Glass enables things like messaging and sensors between devices. And this is really what's going to be most interesting to you as developers. So all of that functionality is baked into the Xbox One Smart Glass apps that are available today. The other things, though, are that the Smart Glass app allows you to access Xbox Live services wherever you are. And so this is a value prop that we give to our users of you are engaged with Xbox. You play games, you have friends, there's a social aspect, and the Smart Glass app is your window into all of that. So we're driving users into the app to access the services they're already using. And once they're inside the app and when they're connected to the same network as their console, then we light up the features that the SmartGlass platform has, such as being able to use your phone as a gamepad in your home. So no more reaching for the controller and turning it on and pressing A to pause the movie. You can pull your phone out, or you probably already have your phone out. You can just hit pause because it's context aware. Personally, one of the things that I really hate is trying to type in passwords or website addresses, things like that, into the console using a controller. You navigate over letter by letter, and it's really kind of a bad experience. But you already have a controller that you know and you love and you know how to use. You're really great at it. And so that's all available to you in the SmartGlass app. You can use the controller that's on your device to be able to actually input text into the console. And finally, it allows you to experience content in new ways. So content that you may already own. You might already own a game or an app or a movie. And with SmartGlass, you can get a different view or an extended experience into that. And that's what we're hoping all of you will think about when you're thinking about building these things. So now you're probably at the point where you're like, I didn't really want to come to a marketing pitch, and I promise this will be the last slide where I really sell this to you. But it's really important to note that at last count, which was sometime last week, there was 2.8 million downloads across the app stores. So 2.8 million people have downloaded and installed the app today. And we see on average about 200,000 daily users coming back into the app and using it. And so I think that's a really compelling thing as a developer to think about, that there's already people that have this and that use it regularly. So you can engage with those users. One last thing to note is that as of writing, there's about 12 titles that have launched companions or are launching soon. So that's all well and good, but what about the scenarios? What are the scenarios that SmartGlass, that Second Screen really enable? Well, these are some of the common scenarios that the SmartGlass team thinks about. They're by no means an exhaustive list, and I'm sure that you guys can come up with something well beyond anything I'm going to talk about here. But as they are, the most common ones that we think about are secret screen. And this is the idea that you might have a common experience for everyone on the TV in the living room, but you want to present something secret about your game or about your movie or about your app to just one user. Well, with SmartGlass, you can do that. And a really good example of where you might leverage something like this is if you wanted to build a Texas Hold'em game, right? So on the common screen, you've got common cards, you've got everyone's bets, and then each player can use their phone and just see their cards. It's a way to build an experience that would otherwise be impossible to build in the living room. The second scenario we think about is sort of the input scenario. This is I have a bunch of options that I want to present to the user, and I want the user to be able to provide me rich and meaningful input. This could just be as simple as I have a list of things and I want the user to choose from them. And by doing this in SmartGlass, you're giving users the flexibility to do this at sort of their will, and you're not forced to build a bunch of UI that might be really, really difficult to do on a console or at a 10-foot scale. One example of this might be if you were building a game that had a bunch of songs in it, like a dance game or a karaoke game. You might present the song list to the user through SmartGlass, which enables them to pick the song that they want to sing or dance to while somebody else is already doing that on the console. So it gives you a way to sort of collect input while something else is happening on the console. Now there's the sort of 1.5 player experience. And we actually have a much better name for it internally, but I just didn't have time to update the slides. We call it the wingman scenario. So imagine you're playing a game and your friend comes over and they want to help you out, but you're in the middle of a game or they're not really good with a controller. Well, with SmartGlass in a 1.5 player scenario, you can build an experience that they can engage with and that they can be part of the game you're playing without being a full player in the game. Plants vs. Zombies Garden Warfare just recently shipped. They have a really, really great wingman companion, and I'd strongly recommend that you check it out. So another thing that you can build for users with SmartGlass or with second screen scenarios is the idea of stats and hints and timelines. And these things are all things that you could do without Smart Glass. But again, building that 10-foot UI to show this kind of data in a meaningful way can be really, really difficult. And if you can take advantage of the controls that already exist or the things that you might have already built for various websites or other apps that you have, it allows you to rapidly build these things. We'll talk about a specific example coming up. Another scenario that is a little more difficult to describe is sort of this idea of extended immersion. And you can think of this as taking something that might be in the game and bringing it out of the window, bringing it into the real world. So one example of this might be if you were building sort of a mystery game, right? Where the character in the game has a magnifying glass or some sort of device that he uses to be able to see things that are not otherwise there, visible to the naked eye. Well, you could use Smart Glass and you could use Second Screen to actually build that and have the user walk around or look at an image on the screen through Smart Glass and see more detail, see something that's not there. It's really, really compelling, and it's a great way to engage with people. And finally, the common scenario, or the final common scenario that we'll talk about, is sort of the idea of offline companions. And this is the notion that not all Xbox users are going to be at home 24 hours a day sitting in front of their Xbox. It's just unreasonable. People have things to do. They're out and about. They want to engage socially and do other things. But wouldn't it be great if you could actually capture that time when they're not at the console and maybe be able to prompt them and say, hey, you know, if you come back to the game, you can just play, your friend just beat your high score. So let's talk about some specific examples, things that have already shipped. So the team at EA, when they were thinking about Madden for the 25th anniversary, they wanted to deliver sort of a new experience to their consumers or their customers. And so one of the things that's always been difficult to do in Madden is when you're playing a head-to-head game on the couch, local multiplayer, you don't really have a ton of opportunity to select a play and try to beat your opponent in a play-style game. You can beat them with the controller, and it's you know, a very physical thing, but you can't outsmart your opponent because they can see what you're doing. So Madden took the idea of Secret Screen, and they said, hey, we're going to build this view that represents a coach's playbook, and they called it Coach Glass. And as you can see, what you get is you get a view of the different areas on the field where you might select a play to. And then once you pick on one of those, it'll give you recommendations based on what other users that play Madden have done, and also give you feedback on what types of plays your opponent might run or what type of defensive plays they're going to run against you. Now, the second companion we'll talk about, or the second example we'll go through, is Rise, Son of Rome. This is one of the launch titles that came out for Xbox One in November. And they did a really, really great job of building that stats and timelines and secrets experience. So as you play through the campaign of the game, the Rise companion actually walks you through and says, hey, there's a secret coming up. And it's not intrusive, and it doesn't ruin the game for you. But if you're not a super hardcore player, it's definitely something that you would have missed. And so having it there for you kind of takes it to the next level for you. But they also built in a scoring system. So as you play through the game, you'll get scored on how you're doing. And you can go through and see and compare against other friends that you might have in the Xbox world. How are they doing? How did they score on this level? And it kind of creates a little bit of that water cooler moment of, hey, you know what? I beat your score last night, and then I can pull out Smart Glass and prove it to you. And one thing that's cool about the Rise companion is that it actually works entirely disconnected from the console. So you don't have to be at home. You don't have to have the game running. You can just access it anywhere you are. The final companion we'll talk about today is Dead Rising 3. So this was already mentioned in some of the other Xbox talks. But Dead Rising 3 is a game where you run around and kill zombies. Zombies have taken over the town of Los Perdidos, I believe is what it's called. And the folks at Capcom said, hey, you know, at some point in the game, the main character, Nick, gets a phone. And that's how survivors get a hold of him. And that's how they're able to talk to him and say, hey, I need more help. Well, wouldn't it be great if we could actually take the phone that's in people's pockets and give them that same experience? So that's what they did. They built a phone UI that here I'm showing as a tablet, but it works and it looks the same on phone. And while you're playing through the game, you'll receive phone calls from survivors that you wouldn't otherwise get. So they've added a little incentive for you to actually go and use the Smart Glass experience. Of course, they provide all the functionality that you would expect from a mobile phone, such as I want to look at a map of where I am, or I want to look something up and find out how do I get here, or how do I get that. So with that sort of in mind, this is your call to action here. Hopefully all of you guys are thinking of ways that you can bring second screen or bring extended experiences to the apps and the games and the things that you build. And today we're talking about Xbox, but the ideas of second screen and the ideas of extended experiences exist everywhere you look. So a great example from inside the company is if you've used the Office remote application or the PowerPoint remote application, I could be using my phone to control this presentation instead of a presentation remote. That's just an example of how non-game scenarios can use second screen as well. So you're all developers, and you want to know how do you actually build these things. Well, we have a lot of stuff for you as developers. If you're building stuff on the console, we have a set of APIs that's available to you regardless of whether you're building an app or whether you're building a game. It's exactly the same set of functionality. It's exactly the same set of APIs. If you're familiar with Smart Glass from the 360 timeframe, you've seen hosted companions. These are companions or second screen experiences that are web-based, and they run inside a hosted browser in the Smart Glass app. So we have an SDK for building those things. And all of the mobile developers out there said, hey, that's really cool, but I already shipped an app, and I don't want to go and port all of that to HTML5. So can you just give me a way to add Smart Glass functionality to my apps today that exist and that I've shipped? Well, we heard you. We heard that feedback, and we worked really hard to make that possible. So we're actually shipping now a native SDK, a set of libraries that you can drop into your apps or into new apps that you want to build. So just to kind of go through each of the SDKs, the hosted companion SDK is our development kit that allows you to build Smart Glass experiences using web technologies that you probably already know, HTML5, JavaScript, CSS. The activities or the companions that you build are surfaced to the user by the Smart Glass app, and the Smart Glass app takes care of all the connection and all the communication and all that stuff. You'll just know that when your companion is running, you'll know what's on the other end, what's on the console, and you'll know when you're connected. We ship a bunch of tools to make it possible and make it easy for you guys to do this. So we're going to be shipping a tool that allows you to rapidly prototype these things inside your browser. It's a bookmarklet that allows you to basically inject events that would normally come from the Smart Glass app. We have already shipped a tool called Smart Glass Studio that's available as part of the Smart Glass SDK, and it allows you to basically test your experience, test and develop your experience end to end. So you'll connect to your console, you'll see a bunch of logging information that the app doesn't surface to you, and then you can load any companion URL you want. So it's a great way to sort of test on your local box or your local dev environment. And the last sort of tool that's available to you if you want to build a hosted companion SDK is the Smart Glass apps that are in the store today actually have a developer facility built in, and you can activate that and then test and see what the end user experience would look like. So what you'll see there is you'll go into the Smart Glass app, you'll see your companion presented as an end user would. You'll be able to interact with it and sort of get that full end-to-end experience. So maybe you're not into the whole HTML5 thing. Maybe you think that's not going to catch on. Or you've already shipped an iOS app or something like that. So we shipped a native SDK, and it's a set of libraries, as I mentioned before, that you can integrate into existing applications or new applications. It is the exact same set of libraries that we use to build the Smart Glass applications. And this is, I think, a really important thing to mention because it means that you guys can build the same set of experiences and the same set of functionality that exist inside the Smart Glass app today. On each platform, you're going to use the native language to that platform. So on iOS, you're going to use Objective-C. On Android, you're probably going to use Java. And on Windows and Windows Phone, you have a couple options, but in general, you're probably either going to build a HTML5 or a WWA app or a native app. And one of the great things about the native SDK is that it allows you to take advantage of some of the existing third-party frameworks and tools that have shipped today so that you can really build amazing experiences. For example, you can use Unity or Unreal inside your Smart Glass apps to just blow the user away. And one final thing that I think is important to mention is if you choose to use the native SDK, you have all of the same monetization options available to you that you would if you were shipping any other mobile app. So if you decide that you want to sell your Smart Glass Companion, you want to make your app a paid or a premium app, you can absolutely do that. So as I mentioned before, we sort of have the HTML5 world, we have the C++ or the native code world. But one thing that we're increasingly see developers go towards is they want the best of both worlds. They want to be able to target all devices with HTML5, but they want to build a really, really rich and exciting experience where their users are. So you know where your users are, and maybe for your particular scenario, most of your users use a particular Android phone that has a barometer, and you have this great idea that wants to take advantage of that. Well, what you can do is you can build a hybrid application using the native SDK and the HTML5 host control that we use in the Smart Glass apps so that you can build most of your application as a hosted experience. And then you can just build that extra little piece of functionality for your users in native code. All right, so that's a lot of me talking about Smart Glass and what it is. Let's actually take a look at how you might build one of these things. First thing I'm going to do is see if my app deployed. It did not. All right. So this is normally what I'd plan to do is actually show you what we were going to build and then we were going to go build it. We're going to try to do it the other way and see what happens. All right, so I've got close that. What I've got here is I've got a game project. Okay, so this is code that's going to run on the Xbox. And we took the idea, or it's a sample actually from the Windows SDK called Marble Maze. And what it is imagine one of those old wooden games that you move around and a marble moves along and you try to get it past some holes in the maze. So somebody on the Windows team thought, hey, this is a cool example of a game that we could build in DirectX, so let's go build it. And what the Xbox team did is we took that and we ported it to Xbox One and then said, hey, well, let's wire up a controller. But what if we wanted to use something else for input? Say, for example, a mobile phone. One right here. This mobile phone has an accelerometer and a gyroscope, and wouldn't it be cool if somebody could sort of directly manipulate the game using their phone? And so what I've done is I've gone and I've added some code to our title to hook in Smart Glass to it. So what I've got here is we built a class that encapsulates a lot of the functionality of what our game is going to need. And the first thing we want to do is when a Smart Glass device connects, we need to know about it. We need to change our behavior based on that. So what I've got here is I've got some code commented out that creates a new device watcher. And the Smart Glass device watcher is an object that you use to subscribe to these device added and device removed events, which you can see right here. Now, that's great, but what happens if a device was already connected before our title launched? I mentioned before that Smart Glass provides some facilities for doing app management. Well, our users might have actually launched our game from within Smart Glass already. And so we need to make sure that we don't miss those devices. And we do that by looking through all the connected devices that already exist. And so there's a function to do that called findAllAsync on a Smart Glass device. And when it's done, it's an asynchronous call that when it's done is going to call a callback that gives us a list of these devices. So what I've got here is I'm going to go through the collection of devices that I received. I'm going to check to make sure that we actually got some. And then I'm going to loop over each one of them. And this on-device added function that we've got is exactly the same function that we passed to our device added event in the first step. So now we know that we have a new device connected. We want to track some state about that. We want to actually create a thing in our game that's aware of this. And so we have this SG device class that I created. And since I mentioned that we want to use the accelerometer, we have some state variables that track what the last value of the accelerometer that we pulled from the accelerometer was. So we're going to go through and we're going to initialize the device. We're going to say, hey, we know you've connected and we want you to show an HTML surface. There's a little bit of legacy in this API. So you might think, well, if I'm building a native app, why do I need to do this? I won't go into all the details, but the reason is that a lot of the messaging APIs actually exist off the HTML surface. So even if you're not necessarily using it, that's where the APIs are going to live. And the next thing we're going to do is we're going to check and say, hey, does my device actually have an accelerometer? And this is important because if you connect, say, a Windows PC that doesn't have an accelerometer, it would be great if we could kind of just ignore that. This companion is not going to provide any functionality for that user. So we're going to check and make sure before we continue. In the case of not having an accelerometer, we're not actually going to do anything for this user. We'll keep track of them, but we're never going to send them anything interesting or expect input from them. But for the devices that do, we want to hook up an event so that when the accelerometer reading changes, we can actually capture that data. So if I jump to that function, let's just go ahead and scroll down. I'm not sure why Object Browser came up. If we jump to this function, the onAccelerometer reading, all we want to do is we want to copy the values from the device. Because in our game loop, when we go through, we're just going to use whatever the latest data that we have is. We're not trying to build something that is like perfectly representing the state of the device. We just want a rough approximation. So we'll just copy the values out. We'll cast them to float, since that's what we're getting from the controller. All right, well, that's great. But how does the device know that it actually needs to start sending us this data? Well, we have a game state built up in our game, this idea of whether I'm on a menu screen or whether I'm in a game or whether the user's died, that sort of thing. And so what we're going to do is later on, we're going to send that message to the device. And how we actually do that is this piece of code here. We create a JSON message. So all of the messaging that's available to you as developers is JSON-based. And we're just going to create a JSON string that has a certain format that we've sort of came to an agreement about in our team. And we're going to send the state of the game and then the controller type. And all you have to do to send that message is call submit message async. All these messages are delivered over UDP, but they're all delivered reliably. So you know if you call submit message async, the message is going to get there eventually. All right. So now, how do we actually hook that up into our game? So I mentioned that we had this notion of game state that existed in our game, and that at some point we would want to send this data to the devices. So we have a function that we call anytime the game state changes. It's called setGameState. And what we're going to do is we're actually just going to tell our SmartGlass controller object that I showed you initially that I want to send the game state to all of the devices that are connected. And so if I was to look at the details of this function, what's actually happening is it's just looping over the devices that we know about, and then it's sending the message to each individual device. All right. Now, what's the first thing that our users are likely going to see, though, when they launch the game? They're probably going to see some sort of menu. And it would be really great if they didn't need to pick up a controller and actually navigate through the menu to start the game. It'd be great if they could just do that from SmartGlass. So in our game loop, we have an update function that goes through and it processes all this input. And so this is the code that we have today that exists for handling gamepad input. We loop over the collection, and we look at the values, and we store some state about it. All you have to do to support SmartGlass devices is actually do the same thing for navigation controllers. So gamepads are exposed to the system both as a navigation controller and as a gamepad because gamepads have things like analog inputs. And smart glass devices, the smart glass gamepad object doesn't actually expose that today. So let's go ahead and uncomment this code, and I'll walk you through it. So we have a navigation controllers collection, and we're going to loop through, and for each controller, we want to check and see, have we already looked at this controller before? And so since we've already processed all the gamepads, we want to treat gamepads as gamepads, and we only want to look at smart glass devices here. So if we find the controller existing in our collection, we're going to skip over it. If we don't find the controller, what we want to do is we want to add new controller state. And you can see here that we're going to call new controller state, and we're going to pass in nav controller get navigation reading. And what this does is this returns a set of basically what the button presses are, what the state of the buttons on the device are. After that, we have a function that goes through and loops all of this combined input and then processes it and does the right thing. And we don't actually need to change anything now. It's all taken care of. So now, the last thing that we probably want to do is we probably want to actually hook up this accelerometer so that when a user is playing with smart glass, we actually take the values from there and not the values from a gamepad. And so what I've done is I basically just want to check that we actually have smart glass devices, and then I'm going to override whatever input's there. If you were building a real game, this is probably not what you would do, but for the purpose of the demo, it'll work. And that's it. That's all we need to do to connect smart glass up to this game. But we've only talked about the Xbox now. So that's great. We've built an Xbox game. And if you're not an Xbox developer, maybe that's not that interesting to you. So while this is building and hopefully deploying to the console, let's go ahead and take a look at what building a companion might look like. So if I switch over here to these devices, you can see I have two devices here. I have a Windows Phone and I have a Nexus device. And this is the companion that we're going to build. So I've got some UI that says what the companion is, and then I've got some buttons. And over in the corner, I have a little log widget that comes up that is a component that we provide to you as developers that makes sort of debugging and diagnosing these things really, really simple. I'll show you how to integrate it in. And just so you're aware, this is actually running inside of Smart Glass Studio. So if I come over here, you can see I've logged in. There's some information panes if you were building a media application. There's some status about whether or not I'm connected to the console, what the active title is, all that sort of stuff. All right, so how do we actually build this now? So I mentioned that this was an HTML5 companion. And so what I've got is I've got an HTML file here that has our basic UI. We've got a body for the game. We have a header. We have some buttons that all have the same class. And each of the buttons has a value. And this value comes from an enum that's defined in the Smart Glass hosted companion SDK. And the reason why they're just numerical values there is that was the easiest way to make this work in a quick and easy way. So you'll forgive that. Now, the first thing I did when I was building this companion is I needed a way to be able to debug and see what was going on. And so I dropped in the log widget that we provide to you. And all you have to do to use it is just include one line of script in your body. So now that that's there, what I want to do is when the Smart Glass companion loads, I want to go through and set some state, do some initialization. And so what you do is you call XBC. There's, again, some legacy there. It should actually probably be Xbox Smart Glass or something like that, but it's called XBC. And there's a loaded event that we're going to pass a function to that will get called when we've actually connected or when we've actually loaded the companion. So what I'll do is I'll capture the state of the world when the companion is loaded, and then I'm going to do some quick checks to say, hey, do I have an accelerometer? In the case of not having an accelerometer, what I want to do is I want to send a message. I want to tell the user, hey, this device doesn't have an accelerometer. This companion is not very useful to you. And so I'll call a function that I defined called log. And all log does is it goes through and it checks to see if the log widget is defined. So have I put the log widget in my page? And the reason why I wrap this like this is that all I need to do when I'm ready to ship my companion is remove this one line of code, and I don't need to change anything else. It's a handy little trick as somebody that's debugged a lot of companions. All right, so now that we've got our companion loaded, we know it's ready to go, we know we have an accelerometer. How are we going to handle when we actually receive a message on the device? So I mentioned before in our game that we hooked up sort of an event handler for when the game state changes. And we send this JSON message that's this agreed upon format. And this is what the format looks like. It's got a type, the particular type of message it is, and then it has some data that we care about. So in the case of game state changed, I want to go through and I want to do something with this. And what I've done here is I've tracked the previous game state, and I update it as we go every time I get a new change. And then I'm going to compare it to the current game state. And if we've made a transition from not in a game to in-game active, which is this first block of code here, all I'm going to do is, if the device has an accelerometer, I'm going to start it. And the parameters that we pass to the start function, they're all documented in the doc, so don't worry about writing this down or anything like that. But what we're going to pass is we're going to pass an interval at which we want to sample the data, and then some flags that tell us, hey, I want to actually receive this data or not on the console or on the device. And so if I wanted to build a really, really rich UI where I had a ball that moved around on the device that matched what's on the console, then I would set true in both of these cases. But since this is just a simple demo, all I want to do is just send it to the console and let it deal with it. And the final thing that we pass to this function, and in fact you should pass to any of the XBC functions that interact with the console, is the destination of the message. So on the Xbox One, you can have multiple apps running at one time. And so this is sort of an important thing that you need to do. It's a difference between the 360 model and the Xbox One SDK, where you actually now need to tell us, hey, this message is destined for this title. And then the final thing I'll do is I'll update some UI. And in the case of transitioning out of in-game state, I want to just stop the accelerometer. I want to be a good citizen and not kill the user's battery. All right, so the last thing we need to do in our companion is we need to wire up these buttons to make them actually useful, so that when the user taps on them, we send something to the console. And we do that by calling XBC gamepad send. And we create a gamepad data object that has a bunch of parameters. And so what I did is I defined a single handler on all of my game button class objects. In this case, I've got a pause button, a boost jump, or a boost and a jump button. And they each had that value that I talked about earlier. So all I need to do is write one function to handle all of my input. And with SmartGlass, with the new APIs, you have the option of triggering button presses or triggering gamepad data. The difference being button presses are treated as a down-up, so we handle internally for you clearing the input after. But I chose to use just a traditional gamepad model where I'm explicitly saying after 100 milliseconds, I want to set the state back to clear. So let's flip back over here. Let me do one quick check as to why this is not working. This will be a lot more interesting if you guys can actually see it. Just going to try restarting the console. While that's happening, I'll come back to the demo at the end if it starts working over here. So what are the next steps for you guys as developers? If you're not already an Xbox developer, we have an indie program that you can go and register for. Currently today, we have about 250 titles that are sort of in the works. It's not yet open to everyone, but we encourage people to register for it so that when we do open it up, you'll be able to go. If you are an Xbox developer, you can go to developer.xboxlive.com, and all of the documentation, all of the SDKs are there for you. And if you happen to be a middleware or a developer partner, so you build apps for other people or you build tools for other people, there's an alias, xboxdpp at microsoft.com. You can contact them and engage with them, and they have some questions that they'll ask you about how you can sort of integrate smart glass into the tools and things that you're doing. We have some great Xbox One and Kinect sessions. I'm the last one for today, but tomorrow there's 3 different talks. I would encourage you to go check them out if you're interested. I'll leave this slide up at the end. And then we have some time, I think, for Q&A, but I'm going to try the demo one more time. So if you maybe want to think about your questions while I see if this works here. My console's still booting. So maybe if there's any questions now. There's no questions? All right. We'll see if the Xbox boots up. So one other fun little fact about the sample that I was going to show you is it's actually multiplayer. So we thought it would be really, really funny if we built a game where you had to work with somebody else. So each of you actually only gets to control half of the board. And it resulted in some pretty entertaining shouting matches in the office. All right, so let's try deploying now. Looks a little better. Just gonna check. Yep. All right. Fortunately, this is a rather large package that it's trying to copy over, so I'll leave this up so you guys can see the progress, and we'll know if it works at the end. Deploying our last set of resources. Yeah, sure. Whatever's easier for you.
Saw some really interesting stuff earlier on about how you could develop an HTML5 on the Xbox from Rob, I think it was.
Right, yeah.
Is there any plans to integrate what we're seeing here with that, so you could have HTML5 both sides, or is...
Yeah, absolutely. So the APIs that exist today are available in whether you're writing a DirectX app or an HTML5 app.
So you could build it in HTML5 on the...
Yeah,
okay.
yeah, absolutely. It's exactly the same set of APIs, in fact. All right. That looks a little better. So what I'm going to do is I'm just going to reconnect. Does anybody want to come up here and give this a try? Nobody? I figured that would be the response. I feel like Rob should come up after his great talk this morning.
I'll give you a hand. You guys can see how bad I play this game.
So Rob's actually never seen this before, so
That's my first try.
we'll see if this works.
All right.
Connect. There we go. This device is not connected, but this one is. I've had some connectivity problems.
Cool, man.
All right, so if you just, I'll hand that to you.
So is the goal to hit the wall or not hit the wall?
The goal is to not fall in the hole.
All
And
right.
you'll see them. Let's see.
There you go.
I think we're having some connectivity issues because I was able to control the menu, but it looks like the game's not actually launching. So we're not sending, our messages are not, yeah, I'm disconnected. All right, sorry guys. Unfortunately, the demo's not going to work. Is there any other questions? Do you want to see what an HTML5 app looks like? Yeah. All right. Let's see if I have one for you here. I was going to walk through some more code since we've got another 5 minutes. Actually, so this is actually a sample that we plan on shipping in the next couple weeks. It's not available today. And actually, the Marble Maze sample is the same. It'll all be up online for you. So this particular sample is really, really simple. All it is it's just a single page. It's got a message box or an input field and then a button. And if I go over and look at sort of the JavaScript that goes along with it, when the app activates, I create an SG handler object. And inside that, you can see that we've got sort of the same ideas. We have a device added, we have a device removed event, we have a message received, and what this particular sample does is it just echoes back a message. So if you send a message from the device, it echoes it back. And so all you need to do is basically the exact same things that I talked about: create a device watcher, hook up the events, enumerate existing devices, and then wire up your received and send events. And that's it. So it's really, really straightforward. All right. If there's any other questions, I will leave you guys with the handy QR code to leave feedback. Definitely do that. Apparently there's prize drawings. Nobody told me that. And thanks.